So in the previous class, actually two classes I was taken previously. So that is related to the stack. What is the stack and what is ADT? So before discussion that stack, I was explained what is ADT, abstract data type, and after that, so we go on for the stack. What is the stack? Basic example I was explained. And after that, stack implementation using arrays and as well as using linked list. Both we seen that. So how to implement this stack and implementation also explained. Okay, using array and as well as in the linked list. So linked list with the linked list I was explained with the code also. Okay. So after that, in the classroom, I explained so what is the applications of stack. So where we can apply the stack according to the syllabus. Okay, the syllabus, whatever the examples was given, so that same examples was taken. So this and we seen some examples, applications. And some few examples are still pending. So one example was pending. So prefix notation to infix notation to postfix notation and for to postfix notation evolution. This example was pending. So whenever you are came for the offline classes, so at that time we will see that example, and also we have a practicals. We have practicals for that. Okay, so that's why. So we will discuss that also in the practicals. So that's the previous status of the class. So so the next topic it is the queue. So like a stack. So queue is also be one of the so abstract data type. By using this, we can arrange the elements in the linear fashion. So in different method, it will follow some different approach to store that data. But whereas the stack, so it will follow their own so process. So where the stack it process whenever the element was came, immediately we need to so store in the stack. So, but when you are going to remove the element, whatever the last element it is inserted in the stack, that element is going to so removing. Okay, that is we call as a pop operation. Okay, push operation. We are keeping the data in the stack. We call it as a so push operation, and where so removing the element from the stack we call it as a pop operation. So here the inserting means pushing the data in the data structure, stack data structure, and as well as removing the element, it will be done at only one side. Okay, even if you see that, I just draw the when my 1 minute. I will take. Okay. So you see that this, let us example take it as a stack. Okay, so this is stack storage means it contains the elements. So these elements so will be okay like this 1 5 or 6, okay, 3. Okay, so this is the elements, and these are the index of that particular stack. 0 is the index. Index is nothing but the position, the actual the location of the element in the stack. Okay, so this is the 2 and this is the 3. The index always it is in the sequence and it starts from the 0. Okay, so and up to some so location. Okay, so this is the last of the stack. Okay, this is the end of the stack. So this we can say it is a so the size. Okay, this is the size of the stack itself. So you see that the main so the inserting the elements in this stack and removing the elements from the stack, it is done from only one side. Okay, you see that, let us assume this is the side, one of the side, and this is another side. Okay, so then we say that the stack, this is the so one side and this is the second side. The inserting as well as the removing is going to doing in the only one side. Okay, that's the so stack process. This is a stack process. Okay, so but when you come to the queue, it is different. Okay, but queue is also do the same thing. Okay, whereas the stack is doing the storing the elements. Elements are going to store in the so this particular stack, and as well as the queue is also it is used to store the elements, but the storing process it is different. Okay, and removing process is different. Okay, so that's the difference between the stack and queue. Okay, so here I will just take one example, general example, what is a queue exactly. Okay, so where the stack, so it is doing from one side, you remember this. Okay, and one point regarding to the stack is what are the element we are pushing, okay, into the stack. Okay, for example, 3 was pushed in the stack. So recently, let us assume that 3 is pushed in the so stack recently. So that 3 is only we are going to removing from the stack. Okay, we cannot remove the 6 or we cannot remove the 5. We cannot remove the 1 because the stack process is not like that. It cannot allow the elements in the middle. Okay, to remove the elements or the end also. Okay, only the elements what we are inserted in the so first recently. Okay, so that element is going to remove. That's why first whatever we are inserted. Okay, so it is going to out first. Okay, so first out. Okay, means which element we are going to so removing, that is the first out, the first out, so first in. Okay, that's why the process of the stack is follows the first in, first out. What are the first is going to inserting, that is going to so out. Okay, so first means recent. Okay, so that is a recently. Okay, what we are inserted, that's the stack operation. This I think it is very clear, already explained in the class. For just recovering that concept, just I was explaining this. Now coming to the actual our queue, what is our queue? Okay, so the queue, the process, just I will explain with a simple example. So as I told that stack, it is going to inserting the elements uh, in the only one side. Okay, and removing the elements also from the same side. But in the queue, the elements it is not like that. So we are, this is, let us assume that this is a queue. Okay, this is a queue. Okay, so this is the elements, let us take this is the elements which contains in the queue. Okay, so this is the front side of the queue, and we say it is a so rear side of the queue. Okay, so back side of the queue. Okay, so you see this stack is not contains front and back side. Okay, so if so front side and rear side. Okay, so rear we can say it is a rear of the queue. So stack it both contains the front and rears are in the only one side. So queue it cannot, it is not like that. Okay, so the front side it is here, and the rear side is here. Okay, we have two sides, two different sides for the queue. That is the difference between the stack and the queue. Okay, so here inserting, how we can insert the elements, and now how to remove the elements in this Queue ADT. That is very important. Okay, that will difference the from the stack and queue. Okay, that's the only the difference between the stack and queue. Okay, so here, so in the queue, So the elements will be insert from the rear only. Okay, remember this is a very important key point in this queue. So it is that the elements, what are the elements we are going to inserting in this queue? That elements should be insert from this so rear side only. Okay, rear side. This is the rear means the so another side of the queue. Okay, so A elements insert. So next, how to remove that? Okay, so removing is going to done from the front side of the queue. This is the front side. Okay, so front side ये है, ये rear side है. Okay, so अभी the removing is going to done from the front side only. So what are the element which is in the next front side? Okay, so ये front side हो जाता है. Okay, this is the first element in the front side. So this is the rear element, the rear position. Okay, so Q को rear में ये last रहता है, ये starting of the front side. So front side में जो element है, first element है, so that element is going to removing from the Q. Okay, so that is the so operations what we are going to do in the queue. So inserting element is going to so inserting from the rear side and removing the elements is going to done from the so front side. Okay, so that is the difference between stack and the queue. So this is the difference between stack, main difference between the stack and queue. Okay, so here that technically we need to say that insert operation and delete operations, so we need to use different terminology. So the inserting elements from the rear side we call as a NQ. Okay, just technically the name we need to use as this. Okay, inserting. Okay, instead of inserting we need to take the different terminology because it is a Queue ADT. Queue related terminologies we need to use it. So that's why the operation whatever we are going to doing, the inserting operation in the queue, it is called as a NQ. Okay, so because entering some value into the queue, you can understand like that also. Okay, so NQ means so entering some elements into the queue, that is a NQ. And whatever we are removing the elements, okay, removing we need to always we do it from the front side of the queue. So removing of the elements from the so queue we can need to say as a so DQ. Okay, so these are the terminologies always we need to use it. Okay, DQUE. So DQ operation. Okay, so delete operation नहीं बोलने का, what is the DQ बोलने का, deleting from the queue element. Okay, this is the terminology. Okay, and this is the basic two main operations like in the stack. So basically in the stack we have the two main operations. What is the two main operations? It is the so push and pop. Instead of the removing and inserting, we need to use it the stack related terminology. It is a push operation and the pop operation. Okay, so this is the basic so NQ and DQ operations in the queue itself. Okay, so this is what we already explained. Okay, so now other main other operations which is there in the queue. This is a list of the so operations which is going to we can do it. Okay, other than this DQ and NQ. Okay, the first operation it will gives the first element in the queue. Okay, so first element which element will become as a first, here the whatever the element it is in the front side. Okay, so front जो होता है तो front side में first element जो भी रहता है वो so वो that will become as the so first element. Okay, if you see that in this example, so this element, okay, this element is the first element. and this is second element, this is third element, and this is the fourth and fifth element. Okay, so this is the first element in the queue. So that's why always we need to remove it from this stack. Okay, first element only. So that's the first operation. First operation. So it will use the what is the first front side of the element. So next is empty. So already we know that. What is that? It is a queue whether it is empty or not. Initially, always the queue is empty. Whenever we are going to doing the operations, when we are inserting some elements into the queue, so the element size of the queue will increases. But at initially, so the stack is going to empty. So we need to check that, because sometimes so whenever the queue is empty, but still you are going to removing some element. The queue operation agar perform kar rahe, so the queue is empty and you are deleting some elements on the queue. So in that case, that operation will get fails. Okay, so it will raise the some exception. So that's why you need to catch that. Okay, exceptions, वो exception हमको handle करने के लिए ये जो function है हम use करना पड़ता है. Is empty, it will use the whether the queue is empty or not. If it is empty, we immediately check that condition, and if the condition is false, okay, it means true, sorry, if the condition is true, is empty is true, then we can display some message like the queue is empty. Okay, so we cannot cannot remove some elements from that. Okay, so that we can a message insert in the so queue. Next size. If you want to find the size of that particular queue, how much size it is, means that the size always it indicates the how many number of elements in the queue. Okay, so the size is always it gives the number of elements. Okay, the count of the elements. Okay, from front side first element से so rear side last element तक. Okay, so बीच में कितना elements है, total number of elements, that will give the size of the so queue. Add to string. Okay, it is not so important function. Okay, this is the main so functions which is we can apply on the queue, which we can implement on the queue. Okay, first one is the dq, removing the elements from the front of the queue, and nq means adding the elements at rear of the queue. First function, it will returns the front of the queue, first element of the queue, and is empty function, it returns the whether the queue is empty or not. If it is empty, it returns true, otherwise it will returns false. And next size, the size it will use the number of elements in the queue itself. Okay, this is the basic so main operations. Okay. Okay, students, one small announcement for you, because we are using Zoom. It will contains only 40 minutes time. So already 40 minutes time is going to complete in 5 minutes. So automatically it will disconnect. So once again, use the same link and join it in the so class. We use the same link. Okay. If the class is terminated in the middle, so then immediately you rejoin using the same link. Okay. So because just Zoom is having some limitations. Okay. Okay, so this is the DQ and NQ and operations. Okay, so now we are going to move forward to the next topic. It is the ये जो DQ है और NQ है वो कैसे implement कर सकता है. Okay, so I think everybody understand the queue concept, and what is the basic idea of the queue, and what is the operations we can perform. Anybody have the doubts in this basic concepts, please raise and unmute yourself and you can ask it. Because for we are going to for implementation, how to implement this queue using two methods. Basically, what are the methods we are using for the stack? The same two methods we are going to use it in this queue also. That is arrays and as well as linked list. Stack is also we implemented in the two methods. These two methods, arrays use kiya hai, linked list use kiya hai. Similarly, in the queues also we can implement using the arrays and linked list. तो एरेस के कैसे हम इम्प्लीमेंट कर सकते हैं और ये हम देखेंगे अभी 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 तक कुछ डाउट्स एनीबॉडी हैविंग सम डाउट्स प्लीज ask me so that we can clarify some doubts and we go further next topic. You can unmute yourself and you can ask it any doubt regarding to this. Okay, so I think so no one is not responding means everybody is understanding. Okay, so going smoothly. So now, so this is queue implementation. Here, if you want to implement this queue, always we need to have two main different. First, we see that using the linker list. So we have the queue concept like this linker list. How to implement this? Okay. So this is the queue pointer. Okay. So in the linker list concept, always you remember this. Okay, linker list. Linker list always it contains pointers. Always it uses the pointers only. So if you not understand pointers, so it is somewhat difficult for you to understand this concepts because the linked list concept is related to the pointers only. Okay, because the pointer is a variable which can store addresses. So here we are not using indexes. Okay, so like in the array. So array generally it is used index values to access the elements, but here we are not using index because the index is not a proper way to use it. But so pointers are the direct addresses, direct address. We can access that element. We can by using the direct address we can access. Okay, index is not the actual address of that element. Okay, so here the linked list is related to that. So pointers are very key, makes a key role in this. Okay, so already explained this pointers, linked list concept in the classroom. So please once again, so I will repeat this concepts related to this queue. Okay, I think it is going to ending the timer. So we will start this so code okay, implementation, linked list implementation. So after the rejoining the class. Okay. So I think all of you so rejoin the class okay once again okay, to for this. After that I will take the attendance. Okay.